Okay, so today's lesson is really just a continuation of what we did in the last lesson with graphing quadratics. Today we're solving by graphing quadratics, and so really all that means is we're going to be doing the same steps we did before. Find the axis of symmetry, the vertex, the points, graphing it. The only addition here is that we're going to be going one step further than that and actually finding some solutions. Let's go ahead and take a look at what a quadratic equation is. Again, we're still looking at that same format, ax squared plus bx plus c. This time we're solving it, so we're setting it equal to 0. Instead of being f of x equals, we're setting it equal to 0. A, b, and c are integers, and that's what we call standard form, the ax squared plus bx plus c. Roots, or solutions, are what we're looking for here. And we also can call those zeros or x-intercepts. All four of those terms, roots, solutions, zeros, and x-intercepts, all of those are the same thing. That's what we're looking for. So in the graph in particular, we're looking for the x-intercepts. So there should be, we're either going to have 0, 1, or 2 solutions to these things. So here's what an equation looks like if it has one real solution. If it has one real solution, that means the vertex sits on the x-axis. It looks something like this because it only crosses the x-axis one time. Two real solutions would look something like this. It's going to cross it 2 times. Once here and once here. It could also go up if you wanted it to. Same thing. Here and here. 2 solutions, 2 solutions. Or it may have no real solutions. Where if it's above and it stays above, it'll never cross it. Or if it's below and stays below, it'll never cross it. So those are the only 3 options we have. You either have one solution, 2 solutions, or no solutions. So let's jump right in with some examples of solving these things by graphing. So our first example here, we're looking at x squared plus 6x plus 8 equals 0. So we want to start, so I'm going to go through a number of these steps this time. So the first step we always want to go with is the axis of symmetry. So we're going to have x is equal to negative b over 2a. So our negative b will be negative 6 all over 2 times a, which is 1. So negative 6 over 2 is negative 3. So that's step 1. Step 2 is to identify where's our vertex. Remember, that's the first part of the vertex. Now I just plug that back in up here. So we have f of negative 3 is going to give us negative 3 squared plus 6 times negative 3 plus 8. So it gives us 9 minus 18 is a negative 9 plus 8 is a negative 1. So our vertex is at negative 3, negative 1. The third thing we do is we want to start finding some additional values here. So we're going to do a table of values. So again, we already have the first one, negative 3, negative 1. So I'm going to go down to negative 2 and negative 1 and see what values we get. So if I plug in negative 2, negative 2 squared is 4, minus 12 is negative 8, plus 8 is 0. Negative 1, negative 1 squared is 1, minus 6 is negative 5, plus 8 is going to be a positive 3. The fourth step, we graph it. And the fifth step is we're looking for what are the solutions. So let's go to start by graphing this. We start by graphing our vertex, which is negative 3, negative 1. And that's also where this axis of symmetry is going to occur. Now we have some points. So I have negative 2, 0. Remember, these mirror. So negative 2, 0 also mirrors over to negative 4, 0. And then we go up to negative 1, 3. And I can mirror image that to negative 5, 3. And that's our parabola. Now remember, these two solutions are where it crosses the x-axis, which would be here and here. So we have x equals -4 and x equals -2. These are the solutions. That's what we're solving for. So after all these steps, these things are all the same. We've done all of this before in the last lesson. This is the only new step, is identifying where does it cross the x-axis. So let's go ahead and try another one here. So I'm going to keep some of these steps up here. Okay. So first, we start with our axis of symmetry. X equals -b/2a. So we have -b, which is going to be a -1, all over 2 times 1. So we end up with a positive 1/2. So when I plug that in, we have f of 1/2 is going to be 1/2 squared minus 1/2 minus 6. So 1/2 squared is 1/4 minus 1/2 minus 6. 1/4 minus 1/2 is -1/4 minus 6 is going to give us a -6 1/4 or 6.25. So our vertex then would be at 0.5, -6.25. Table of values is next. So we already have one value of it, it's 0.5 and -6.25. Now instead of me jumping and doing this by halves, I'm going to jump to 1 and then we can go to 3. So if I jump to 1, 1 squared is 1, minus 1 is 0, minus 6 is a -6. 2. 2 squared is 4, minus 2 is 2, minus 6 is -4. 3. 3 squared is 9, minus 3 is 6, minus 6 is 0. Now we graph it. So axis of symmetry is a positive 1/2. Along with our vertex down here at -6.25. So there's that. But then we can go ahead and jump to that 1, -6, which means we're also going to be at 0, -6. And then we're at 2, -4, which means we mirror image over here at -1, -4. And then we're at 3, 0, which will then mirror image to -2, 0. And again, we're looking for where does it cross that x-axis. What's going to occur at x equals -2 and x equals 3. And those, again, are your two solutions. Wherever it crosses the x-axis, that's the only thing we're looking for here. Where does it cross the x-axis? If you can find that, you found your solutions. So taking a look at a new example here, the first thing you want to do, because this we can't solve it the way it is, we have to get it equal to 0. So I'm going to add the x squared and subtract the 8x to the other side. So that way we have 0 is equal to x squared minus 8x plus 16. Now I can go through my steps. The axis of symmetry, we have x equals -b/2a, which is going to be a -8 all over 2 times 1. 8 over 2 is 4. Step 2 is our vertex. Plug in this value. So we're going to have 4 squared minus 8 times 4 plus 16. So we get 16 minus 32 is -16 plus 16 is 0. So then my vertex is at 4, 0. table of values, x and y. We have 4, 0, so then I'm going to go down to 3 and 2. So 3 squared is 9 minus 24. Excuse me, is going to be a negative 15 plus 16 is going to give us a positive 1. 2 squared is 4 minus 16 is negative 12 plus 16 is 4. And again, we'll mirror image those things. So the axis symmetry occurs here at x equals 4. My vertex is on the x-axis. We have 3, 1, which will mirror over to 5, 1. And then we have 2, 4, which will mirror over to 6, 4. Notice this is one of our different scenarios where we only have one solution because the vertex is on the axis. So when we go down to so step 4 was to graph. When I look at step 5, the only solution I have is x equals 4. And that's the only solution we're looking for there is x equals 4. So far we've had 2 examples where we had 2 solutions, and now this example where we only have 1 solution. And that's whenever the vertex is on the axis, that's your solution. And you don't want to stop there. We could have noticed that over in step 2 where we had 4, 0, but you don't want to stop there. You want to go through and graph the whole thing because part of the points here, part of the credit is going to be actually getting the graph and then using the graph to identify. Okay, let's take a look at example number 3. So it's a little different here. So it says, find 2 real numbers with a sum of 6 and a product of 10, or show that no such numbers exist. So what they want us to say is 2 real numbers, let's call them x and y, so that their sum, when we add them, is 6, and they have a product, x times y, which equals 10. So as we look at these, we can see that we have a system of equations. So when we're doing this, we really want to say, if I were to rewrite this and say, okay, y equals 6 minus x. I can substitute that in down here and say that x times 6 minus x is equal to 10. When I distribute that, I'll pull myself up here, we're going to have 6x minus x squared is equal to 10. I'm going to set this equal to 0, so we have x squared minus 6x plus 10 is equal to 0. And now we're looking at the same thing that we had before, that same quadratic. So we can go through this and do this by graphing. So if I look at this and say, let's find our vertex. So we have x equals 6 over 2, which is 3. When I plug that back in, 3 squared is 9, minus 18 is going to give us negative 9, plus 10 is going to give us 1. So we can say, okay, f of 3 is going to be 1. So my vertex is at 3, 1. What we notice here is that when I were to graph this, at 3, 1, it's here. Notice A is positive, so it goes up. This is a minimum. It's going to go this direction. Will it ever cross the x-axis? No. Since it will never cross the x-axis, there is no solution to this, which means this can't happen. So all we've done here is we've shown that no such numbers can exist. Because when we've done this, so all I did here is I set up x plus y is equal to 6, and then x times y has to be equal to 10. I rewrote this, so that 6 minus x was equal to y, and I substituted it in so that we had x times 6 minus x. When I rewrote this as a quadratic, I got this into the format that we just graphed. Then I started the graphing process, and when I went to solve it, I realized it was never going to cross the x-axis. If it would have, those two places it would cross the x-axis would have been my x and my y values, and it would have shown that those exist. This shows me that it doesn't exist. So let's try it again. Find two real numbers with a sum of 4, so x plus y has to equal 4, and a product of 5. So we have x times y is equal to 5. Again, let's solve this for y. So let me say that y is going to be equal to 4 minus x, and substitute it in here. So now this becomes x times 4 minus x, which is equal to 5. So when I rewrite this, we have 4x minus x squared is equal to 5. Let's add and subtract these to the other side so that we have 0 is going to be equal to x squared minus 4x plus 5. And we're going to go through our solving process, our graphing process, because it's the only way we know right now how to solve is by graphing. So we have x equals negative b, so negative negative 4 is 4 over 2 times 1, or just 2, which is 2. Let me plug that back in and find my vertex. 2 squared is 4, minus 8 is negative 4, plus 5 is 1. So if I have f of 2, that gives me 1. Again, 2, 1, this is moving upward because the a is positive, starts above, it goes up, it will never cross. So we have a very similar situation here. We're at 2, 1, it's going to go up, it will never cross. So again, all we've done is shown that no two numbers exist that can do that. And so these are the examples they've given us of having no solution. So instead of us just going through and regular graphing them, this is just a different creative way of showing that these are the no solution type problems. Now this last example, or these last two examples actually, are going to show us what happens when we don't get exact numbers. Sometimes it's going to cross somewhere in between two numbers and it may not be exact. All that means is we're just going to kind of estimate and guess what our solutions might be. But we go through the same process. Step number 1, the axis of symmetry. So we have x equals negative b all over 2a. So negative b is going to be a negative 4 all over 2 times a this time is a negative 1. So be careful of that. It's not always just going to be 1. So negative 4 over negative 2 is a positive 2. Then we have the vertex. When I plug in 2, we have f of 2 is going to be equal to a negative, careful here, that negative is not squared. Only the 2 is squared. Plus 4 times 2 minus 1. So we get negative 4 plus 8 minus 1. Negative 4 plus 8 is 4, minus 1 is 3. So now my vertex is at 2, 3. Step number 3, we have an xy table. So we already know we have 2, 3. So I'm going to go down to 1 and 0. At 1, we have 1 squared is 1, make it negative. Plus 4 is 3. Minus 1 is 2. At 0, 0, 0, negative 1. Step 4, we graph. And then step 5, we're going to look for 1 or 2 or no solutions. So vertex at 2, 3. We have a point at 1, 2. And then we can mirror image that over our axis of symmetry. And then we have 0, negative 1. So notice this time when I went through, it didn't cross at 2 nice values. So we could estimate what it was. We could also just say that x is between 0 and 1, and then it's between 3 and 4. So it's between 0 and 1, so that's why I said x is greater than 0, less than 1. And then it's between 3 and 4 somewhere, so it's greater than 3, but it's less than 4. And this would suffice for the answers. And it's problems like this that we're going to use different scenarios with later in the chapter. Factoring, quadratic formula, some of those other ways, completing the square. Things we've done before but we haven't done yet this year. Those are the way that we'll actually find these answers. For graphing, this is why graphing can be frustrating, because you might not actually get an answer with this. So this is all the further we can take this one, is just it's in between two numbers. So let's go ahead and try that again, just so you guys can get a better feel for how that might work. Put some of this stuff up here. And this will be our last one. So start with our axis of symmetry. So we have a negative 6 all over 2 times 1. So we end up with a positive 6 over 2 is 3. Let's go and plug in that 3. So we have 3 squared minus 6 times 3 plus 3. So we have 9 minus 18 plus 3. So negative 9 plus 3 is a negative 6. So our vertex is at 3, negative 6. So that's our first point. Let's go ahead and find 2 more points. 2 squared is 4, minus 12 is a negative 8, plus 3 is a negative 5. And then 1. 1 squared is 1, minus 6 is negative 5, plus 3 is a negative 2. Let's graph it. Vertex at 3, negative 6. And that's also where this axis of symmetry is occurring. Then we go to 2, negative 5, which again will mirror image to the other side. And then we have one at 1, negative 2, which will also mirror image. You haven't reached this yet, but don't stop, because remember, that goes infinitely. So keep going until you hit it. So draw the graph until you hit it. Notice we're in between two values here. I didn't hit just the exact value. So this time, again, I'd say it's between 0 and 1. And this time we're between 5 and 6. So as irritating or frustrating as that may seem to not get an exact answer, you could estimate. You could say it's at 0.5 and 5.5. You may guess 0.7 and 5.7 or something like that. But I'm not asking you to estimate, I'm just asking you to find out what two numbers is it between on the graph. And that concludes our lesson. Your homework tonight, well actually for tomorrow, is page 249. You're doing all of the ones 14 to 19, and then just the evens for 20 through 28. And that concludes section 5.2 on graphing, which kind of concludes our graphing for a little bit. We will get back to graphing, but for now this will conclude our graphing section. We're moving on to other things in section 3.